moles, and molarity. Why is it O? Is it too easy? Is it too OMG? I know what a mole is. A mole is a furry animal. That's a nuisance in the garden. And to get started with these moles and molarity, first of all, a very stupid question. What do you call two of a kind? A pair, yeah? Or a couple? What did you say? What do you call 12 of something? A dozen. What is a baker's dozen? 13. Why? A baker's dozen simply comes from the fact that bakers and other tradespeople were punished severely if they didn't serve the right amount. So what they did is, just to be on the safe side, instead of 12, they served 13 bread rolls or something like that. Then they were always on the right side of the law. What do you call 144? Loud? Is a gross. It's pretty gross. What do you call 6.022 times 10 to the power of 23? That is a mole. Exactly. A mole is nothing else but a number. You can have a dozen eggs. You can have a gross eggs. You potentially could have a mole eggs. Right? Not that moles lay eggs, but you can have 6.022 times 10 to the 23 eggs. Would be a huge amount of eggs, but you can have that. So mole is nothing else but a certain number. Don't be scared of it. A mole is not scary. This is also called, what is this called? Avogadro. Avogadro. Has nothing to do with the fruit that you use in guacamole. Yeah, I've seen that in exam scripts. It's avocado's number. So it just tells us how many atoms or molecules are basically in one mole. And in a way, we can even write, we have 6.022 times 10 to the 23 molecules or atoms in one mole. And obviously, I want you to remember that, because this is very, we will use that all the time. Now, of course, different molecules have different weights. Now you can imagine a mole of people weigh differently to a mole of bacteria. They have different weights. How do you find out the weight of a certain substance? Well, it's not terribly difficult. So we said 12, 6 carbon. Here this 12 indicates that 1 mole is equivalent to 12 gram. Or I can write that in a slightly different form. I can write 12 gram per mole, and that is usually called the molecular weight. You see molecular weight, you see molecular mass, all these things. They mean the same thing. 12 gram per mole. Now, carbon is very easy. Let's have a look at something more complex. Let's have a look at water. Now, water, we know, is made up of two hydrogens. Each one has 1, 1. And oxygen, sort of as the number plate, has 16, 8. Here again the 8 means it has 8 protons. Here this number means it has 1 proton in it. If we want to know what is the overall molecular weight of this guy, all we need to do is we need to add these top numbers together, and we find that, I don't ask you, I don't want to insult your intelligence on that, but we know that 1 mole of water is equivalent to 18 grams, or the molecular weight would be 18 gram per mole. Happy with that? So if I gave you sort of a periodic table and gave you a big molecule, you will be able to very easily figure out what is the molecular weight of this compound. You just have to add these things up. If you got that, if you got this concept, you got 1/3 of your degree already. Right? Because this is where a lot of people will fall over. Now let's get the other 2/3 of the degree. As I said, mole is just a number of. So 1 mole, again, equals 6.022 times 10 to the 23 molecules. Of course, I can ask you, what is a micromole? I want to know how many atoms molecules, let's say molecules, be general, molecules are in 1 micromole. Now here comes something extremely handy, something that I showed you last time. First of all, let's write down what we've been given. We have 6.022 times 10 to the 23 molecules per 1 mole. And we have 1 micromole. What is micro? What does micro stand for? 10 to the minus 6. 1 times 10 to the minus 6 mole. These are the two things that are interesting for us. And what we do now is this dimensional analysis that I was talking about last time. Remember? Very vaguely. So, what are we looking for? What is the unit that we are looking for? Loud? We are looking for how many molecules. So the question is molecules. That is the unit, actually, that we are looking for. So we have molecules. That is what we are looking for. In our two givens, I probably should box them in. It's not pretty, but do we have anything with molecules? Any unit? Yeah? Top one. 6.022 times 10 to the 23. Molecules. So let's write it down. 6.022 times 10 to the 23 molecules per mole. Yeah? So we've got the unit that we are looking for on top of this fraction line. Molecule, molecule. Good. But we have the problem, we've got a mole down here. Yeah? And having a mole down here is never a good thing. So how do we get rid of the mole? Operation. Or whatever. So we look whether we have another unit mole, oh la la, and we put it so that this unit and this unit cancel out. So we put that up here. So we would have 1 times 10 to the minus 6 mole. You see what I've done? Mole is now up here, and it cancels out this mole down here. And indeed, it cancels out. So what have I got left? Molecule. I've got molecule left, and that is exactly what I wanted. I want molecule left. Yay! So all I need to do now is I need to write this, and I have 6.022 times 10 to the 23 times 1 times 10 to the minus 6 molecules. That's the unit. Okay? Units are absolutely essential. And now I can do that, and I'll give you an example for the units in a minute. Units are absolutely essential, but I can do that. And we have the same bases here, 10 to the 23 and 10 minus 6. So all I need to do is 23 take away 6 is 17. Yeah? So we've got 6.022 times 10 to the 17 molecules. Okay? Happy with that? Do you get the principle? We will do a few more exercises, but first I want to illustrate to you the concept of units. You want to? You want to? Say loud.
Okay.
Okay. I didn't give a unit. He said, okay. Wasn't okay. I meant actually smack my bottom. Did you want 10? No. Oh, I'm so sorry. I would have given you a 10. You fell for it again. I didn't say what the 10s are. You said just no. No. Right? So, any measure without a unit is, you either win the lottery or you spend an hour with me. Right? And swing both ways. So, yeah, be careful. Units are important. Absolutely essential units. Nobody gets my tenor. Give you another example of the importance of units. A few years ago, there was a collaboration between NASA and the European Space Agency, ESA, and they were supposed to send a probe to Mars. Probe launched, wonderful, everything, and then they realized the probe, Mars is here, probe is going that way. Several billion pounds just, going hundreds of miles past Mars. And everybody was, oh sugar, what went wrong? And then somebody checked all the calculations were okay. But then they figured out the calculations from the ESA, from the European side, they were all done by the Brits. And they used imperial measures. A mile, 10 miles, things like that, yeah? A foot, a yard, a fortnight, things like that. Things that the Americans just simply don't understand. They do, a kilometer. And they drive on the other side as well. And because they didn't exchange what units they were using, I think the probe is now on the way to God knows where. So, units. Units. If I ever catch anyone without a unit, you got my drift? Okay, units. Fantastic. Okay, so we can calculate with this dimensional analysis, we can very easily calculate and we can convert how many moles are in a certain amount of grams. Let's quickly do that. We have molecular mass is, say, 180 grams per mole. I have 56 grams, and I want to know how many moles are 56 grams. 56 grams are equal to how many moles? Okay, so what I want you to do is, for a minute or so, think about the strategy that you want to use to get this result on your own. Please note, I'm asking for moles, I don't ask for molecules here. Yeah? Okay, so you figured out the strategy. Now, tell the person sitting next to you how you would do that. Okay, let's see whether you've done it right. Shall we do it together? Yeah? What is the unit that I'm looking for? Moles. So, let's write that down. Do we have anywhere where we have mole? Where? 180 gram per mole. But this time the mole is at the bottom. So what we need to do is we just simply do a dirty trick and we turn it around. We just simply say 1 mole, 180 grams. Yeah? That is basically what it says. 1 mole, 180 grams, or 180 gram equals 1 mole. So look, we've got mole here, mole here. Yay! Hang on, we've got a gram down here. Bummer. So how do we get rid of the gram? Sorry? Yes, we have the 56 grams. So we've got the grams up here. So we just have to position that, these 56 grams, so that these grams cancel out. So we bring that up here. The grams go up here. So we've got 56 grams. Yeah? What happens? The grams cancel out. Doo-doo. And we have 56 mole divided by 180. Unit mole is still the same. That's all that's left. Couldn't be easier. All you need to do is key that in your calculator and you will get something like 0.3 something, 0.3 mole. Yeah? Robert is your mother's brother. Bob's your uncle. Okay, so you got the mole concept. Let's talk about a slightly different concept. Let's talk about concentration. And I don't want to tell you this old blonde joke because, it wouldn't be fair. Or shall I? Why does a blonde, and I specifically don't qualify the gender, why does a blonde stand in the supermarket and looking at the orange juice concentrate, it says on the orange juice box. Now concentration is just simply number of things, that's very technical, per given volume. So I could do the concentration of people per lecture theatre. Well, concentration of people per, say, 100 cubic meters here. Should be 220. So 220 students, ideally, per 100, is that 100? Maybe. 100 cubic meters. The cubic meters is a volume, right? Nothing mysterious about it. If I put one, wow, it's exciting, huh? 1 mole of a substance into a total of 1 liter, then this is a concentration, isn't it? Mole is a number, 6.022 times 10 to the 23 molecules. And 1 liter, that's the volume. And instead of writing mole of substance per liter, people are extremely lazy, and they just simply write a capital M equals 1 M. Please write a capital M, because otherwise it reads either meter or milli. And we say the concentration of this is 1 molar. And with molar we don't mean the back teeth. It's just simply 1 mole per liter. Pretty simple concept, I would assume. Of course, sometimes we don't have a whole liter. Sometimes we have smaller units, milliliter or so. But it's still the same concept. 1 molar, 1 mole per liter. I can have smaller units. I can have 1 millimolar. Very common unit in biosciences. It just means 1 times 10 to the minus 3 mole per liter. That's a millimolar. Or a micromolar. Or something like that. Yeah? Now very often we have to make up solutions. For example, I want to make up 500 milliliter of 1 molar solution. How am I going to do that? How many moles do I need? How many moles? Any idea how you can address that? Think for yourself. And convince the person sitting next to you that you are right. Okay, shall we do it together? What are we looking for? What's the unit? Moles. Do we have anywhere where we have moles? Well, actually we do, because the capital M means mole per liter, doesn't it? Yeah? So mole is on top. We can put that down here. We have 1 mole per liter. So mole I have, but the liters are a bit of a nuisance. How do I get rid of the liters? 500 milliliters, yes. So I can put liters up here so that they cancel out. But the problem is I don't have liters, I have milliliters. How do I do that? Yes, exactly. I do 500 times 10 to the minus 3 liters. That is what the milli says. Hasta la vista. L cancels out. What have I got left? Mole. What I wanted. No other units. So I need to use 500 times 10 to the minus 3 mole, or that is 500 divided by 1000, that is 0.5 mole, or half a mole. All answers are correct, as long as there is a unit. Yeah? Pretty simple, pretty straightforward. I've sent out an email which contains a link to Unit 2. There are some exercises. Have a look at these exercises. We will go into more detail next Monday then, when I'm back. But try to submit some of the stuff already when you can. Okay? See you next Monday. Be good. Don't do anything I would do.